Okay. So today's topic of the day, we're going to be interpreting and writing real-world expressions. So that's kind of a fancy way of saying we're going to do some word problems today. And these word problems, I know, I already see your faces. Y'all don't like word problems. Get used to it because algebra is 80% word problems. A lot of word problems. So we've got to just get used to it. So throughout the day, because I know you guys are writing everything in your notebooks and that can take a lot of time. So throughout the day, I'm going to tell you what you do write and what you don't write so that you don't spend a bunch of time writing stuff that in the end isn't necessary. So for now, we're just writing the topic of the day. Today is September 11th. Okay, and let's go ahead. Okay, so on this page, I do want you to write each of these sentences, and these are just our definitions for the day. So when you write them down, write them in don't write it as a paragraph, write it as just 3 different definitions. So I'll give you guys 4 minutes to write these down, and then we'll read them together. Only the parts that I highlight. All right, when you're done writing, you can go to the participants button and give me a little check mark so that I know you're done. See 5 check marks. Give you guys about another minute. Good, a few more check marks. One, pick one. There you go, okay. What does that one mean? Need a break. You need a break already? It's only been 10 minutes. Alrighty. Finish up writing. We're just gonna start just reading these out loud. So I've got 4 definitions. Can I get 4 volunteers to read them if you've already finished writing? Starting with an expression.
An expression is a mathematical phrase that contains operation numbers and or variables.
Awesome. So the most important thing to see here about an expression is that an expression does not have a equal sign. Does not have an equal sign, because if it has an equal sign, what is that called?
Equation.
An equation, exactly. So expressions are different from equations. All right, but then they have some similarities. So starting with the terms, what is the term?
The terms of an expression are the parts that are being added.
Okay, exactly. So we separate things out by addition, and we'll talk about that in just a second. All right, what is a coefficient?
The numerical factor of a variable term.
All right, so coefficients are the numbers that we see. And then finally, I want to know the difference between numerical and algebraic expression.
A numerical expression contains only numbers, while an algebraic expression contains at least one variable.
Awesome. So numerical, you kind of see the word number in there. So numerical is numbers, and then algebraic, you see algebra in there. That's because it has variables. All right. So now I have these 2 examples, example A and example B. For these 2 examples, all you have to write down is the expression. So you don't have to write down the words, just write down the expression. So for example A, you're just going to write down 8p plus 2q plus 7r. And what we're going to do is we're going to identify in this expression which ones are the terms and which ones are the coefficients. So I'm just going to write it down. So my terms, remember, terms are separated by addition. So how many terms are there in this expression? See,
3.
2, 3, 3. Yeah. So we're separating everything by addition. So when you look at it, you have 3 terms. You've got AP, 2Q, 7R. Those are my terms. And then my coefficients are the numbers that stick to each of the variables. So if it's right next to a variable, that is a coefficient. So here I have 8, 2, and 7. Those are my coefficients. Pretty easy so far. With example B though, I do want to point out, do you guys see addition or do we see subtraction?
Subtraction.
Okay, subtraction. So when you write this one down, first write it exactly like you see it, for example, B. But we're actually going to rewrite it underneath, and we're going to write the same exact thing, but a slightly different way. I'm going to write 18, and instead of minus 2x, I'm going to write plus negative 2x plus negative 4y. And I'm just doing that so that I can show the same exact expression using addition instead of subtraction. Because remember, the terms are separated by addition. So it's important to, if you see subtraction symbols, you're going to think of it like you're adding a negative number. It's the same thing, we're just writing it a different way. So when I do that, now it's a little bit easier to see what are my terms. Who would like to share?
2x. I mean negative 2x. And
There you go. We have negative 2x. We have, what else?
Negative 4y.
Negative 4y. And what about the 18? Does that also count as a term?
Yeah.
Yes.
Oh,
It
yeah.
sure does. Yeah.
Okay.
And then what about the coefficients? Go back to the definition of a coefficient in case you're confused. And then I would like to hear, what do you guys think? What are the coefficients?
18.
Remember, remember?
Negative 2 and negative 4.
Okay, good. So a coefficient has to have a variable with it. It has to be tied to a variable. The 18 is all by itself, so that one's not a coefficient. However, the negative 2 and the negative 4 are coefficients because they are married to that variable. That 18, she's single. Any questions on these definitions? Expression, terms, coefficients?
Wait, with an expression, you don't find the what is equal to. You just have to find out what is there.
Right. So that's the kind of like the weird thing about expressions is that they don't have an equal sign. So the point, we're not trying to find the answer. It's more like a sentence. So an equation is kind of like a question because you're always going to find an answer. But an expression is more like a sentence. You don't really need to find an answer. It's just kind of telling us something.
Oh.
Mm-hmm. Any other questions? All right. So in algebra, a lot of times you're going to see word problems, and those word problems, you're going to have to figure out how to write that using an algebraic expression. So we're going to do a few examples, and with these examples, let's see, we have 3 of them. You do not need to write down the entire word problem. The only thing that you need to write down is the expression. So I'm going to read letter C out loud. Oh, did it not change?
No.
My bad.
No.
Y'all know how it is at this point.
That's all we had to write.
Okay, so you do not have to write the words. I'll highlight the parts you need to write. So I'll read it first. Tickets to an amusement park are $60 for adults and $30 for children. If A is the number of adults and C is the number of children, then the cost for A adults and C children is 60A plus 30C. That's all you need to write down right now. 60A plus 30C. And what we're going to do is we're going to break it down. This is an expression. It has numbers, variables, coefficients, all the stuff that makes it an expression, but it actually means something in real life based on this problem. So what we have to do is the question is, what do the coefficients, variables, and terms mean in the context of this situation? So we're going to explain what each of those things mean in this specific example. So what I'm going to do is I'm going to write it down. So first we're going to break it down. First thing I want to know is, what are the coefficients?
What they mean, like the whole meaning of it.
No, just what are they? What are the numbers?
60
60 and 30.
60 and 30. 60 and 30. And then we're going to define what they mean. So what does the 60 mean in this context?
dollars
Dollars for what? Be specific.
for adults.
It's the amount the ticket costs for the adults.
Perfect. Exactly. So I like the way you said that. So ticket cost for adults. And then 30, very similarly, is our ticket cost for children, kids. That's our coefficients. Then we're going to talk about the variables. What are my two variables?
A and C.
A.
Good, A and C. And we're going to read it straight from the problem. What does A represent?
Adults.
$60.
The amount of adults.
The amount of adults. So not just adults, but the number of adults. That's very important. The number of adults. And then C, very similar, is the number of kids. And now we put them together, and we're going to define the terms. So the terms put all these things together. We have 60A and we have 30C. But when you put them together, it kind of changes the meaning a little bit, because now what exactly does it mean if I have 60 and A put together? Think about it for a second.
The 60 like shows the tickets for the adults, and then plus the A's for the number of adults. So it's basically saying, what is the cost of the tickets for the number of adults?
You got it. Exactly. So if you're paying $60 for each adult that went to the amusement park, then putting those two numbers, the 60 and the A, together tells you the total costs for the adults who went to the park. 60 is just for one adult. But when you multiply it by the number of adults who went, that's going to give you the total amount for all of the adults. And then you also have the total cost for the children. So this one is definitely a pretty basic example, but no matter how hard the expression might look when you see it, we can always break it down and break it down and break it down until we kind of figure out what each of those little bits mean. So you'll see it's gonna get harder and harder. So with example C, this is like a level 1. Now we're gonna go ahead, and I see a couple people still writing, so I'll give you a couple more seconds. And we're going to do another one. But at this point, do I have any questions? Okay, cool. Okay. Same thing here. Do not write the whole problem down. Just write the expression. Would anyone like to read this example for us?
I will.
All right, go ahead, Lori.
The price of a case of juice is $15. Fred has a coupon for 20 cents off each bottle in the case. The expression to find the final cost of the case of juice is 15 minus 0.2b, wherein b is the number of bottles.
Awesome. All right, so that's our scenario. We're talking about juice. And we're going to do the same thing. We're going to define the coefficients, the variables, and the terms. All right, so here, what do I have for coefficients?
0.2.
0.2. And remember, coefficients get separated out by addition. So in this case, since I see subtraction, I need to kind of think of this as 15 plus
Plus
negative.
0.2b.
Exactly. Which means my coefficient isn't just positive 0.2, it's going to be negative 0.2. All right, and what is that representing in this scenario?
Mm,
20 cents.
Yeah, it's going to be 20 cents. And why is that negative?
because
Because it had the subtraction sign in front of it.
And why did they do that? Why are they subtracting?
Because he has a coupon for 20 cents off.
20 cents off, exactly. We're subtracting because it's going to save him money. So this is 20 cents off. And it's off of what? Is it 20 cents off of the total or
Each
something?
bottle.
Off each bottle, exactly. Okay. What about our variable?
B.
That's B. And what does B represent?
Number of bottles.
Number of bottles. Easy enough. Okay.
Miss, you put 2 on
What?
in variable.
Oh, that's an I. My bad. All right, so we've got the variable, we got the coefficients, and then we have terms. How many terms do we have?
no.
2, 15, and 0.2.
Good. 15, and then negative 0.2b. That whole thing is a term. Because remember, terms are separated by addition. All right, what does the 15 represent?
The price of a case of juice.
Mm-hmm.
The cost of a case of juice.
A case. And is that before or after the discount?
Before.
Before. So this is the price of a case without, this means without a discount. So you start off with 15, and then negative 0.2b, you put those together, it gives you a brand new context. And what does that mean now?
The total cost.
The total, I would use a different word than cost. Think about it.
The final. The total.
Price.
Final price, kinda.
Discount.
Discount, she's got it. The total discount. So this is going to tell you how much money you save. 15 is what you start off with, And then negative 0.2b will tell you how much money you can take away from that. So, okay, so are we kind of seeing how it's with these types of expressions, each little part of it means a different thing, but when you put it together, it tells the whole story. So the whole story at the end of the day is what I'm going to pay at the store. And it depends on the type of case, because I could buy a case of juice that has 20 bottles in it. I could buy a case of juice that only has 3 bottles in it. And my total price at the end of the day is going to be different because it depends on how many bottles are inside that case. Okay, so any questions on this one? All right, let's kick it up a notch. Here we go. Again, only write the expression. And I know this one's a little bit longer, but would anyone like to read it?
Jill is buying inkjet paper and laserjet paper for her business. She buys 8 more packages of inkjet paper than P packages of laserjet paper. Inkjet paper costs $6.95 per package, and laserjet paper costs $8 per package. What does the expression 8P plus 6.95
Parentheses.
parentheses P plus 8 represent?
Okay, so we're adding parentheses. Things are getting interesting. This is still, we're going to break it down. So with this problem, it's going to be very important to read it carefully. Okay, so as we go, I'm going to go back to the text and I'm going to highlight or underline some important parts. But let's just start off with the coefficients. So what do we see as far as coefficients?
8
We see 8
and 6.95.
and 6.95, yeah. The
Okay,
6.95,
see.
say that again?
Okay, see you like writing.
Oh, I'm sorry. Let's see if I can fix that. There we go. Okay, so the 6.95 is also a coefficient, even though that there's parentheses, we're still going to think of that as a coefficient, because remember with parentheses, you can always distribute, and if you distributed, it would be just like a normal coefficient. So 6.95 is also a coefficient. And what do these represent?
The cost of inkjet paper.
Good. So there's inkjet paper, and then there's laserjet paper. Do not ask me what that means, because I have no idea what that even means. But all I know is there's 2 different types of ink for whatever reason. So $8 goes with the laserjet paper.
Cost of laserjet.
So cost of laserjet. I'm going to call it laserjet paper, LJP. And then $6.95 is the cost of
Inkjet paper.
inkjet paper. IJP. Alrighty. Now we go to variables. There's only one, right? Just P. But go ahead and reread and try and see, what does P represent?
Per package? Well, no. Packages of laserjet paper.
Yeah. So they love to phrase things a little weirdly, but here, if I read, I'm going to read sentence number 2. So, she buys 8 more packages of inkjet paper than P packages of laserjet paper. So P packages of laserjet paper tells me that P represents packages of LaserJet paper. So number of LaserJet paper packages. Okay. And finally, we do our terms. So remember, terms are separated out by addition, but in this case, I also have parentheses. So since that parentheses has addition inside of it, since it's inside parentheses, it's protected. So we don't count that. Okay, so really you only have 2 terms. I know that's a little.
I can't see.
You can't see it.
No.
Are you on your laptop or your phone?
I'm on my laptop.
Okay, go to somewhere on the top. It should say View Options, and you can change it to side-by-side mode, and you'll be able to see the whole screen. And then on the side, it'll show the people. It'll show me.
Thank you.
You're welcome. All right, so my terms are 8p, and then 6.95 times p plus 8. Start with the easy one, right? 8p. What is that telling me?
The cost
Mm-hmm.
of LaserJet paper per package.
Exactly. So you were saying the right word at first. The total.
I was gonna say total, but I changed it.
Total cost for LJP, for LaserJet paper. And remember, the difference between 8p and then just 8 is that the just 8 is for 1 packet of LJP. But 8p tells us the total cost for however many packages I decide to buy. So it could be 1 package, but it could also be 8. It could be 20. It could be 25. I could buy as many packages as I want. As a teacher, I would probably buy like 100 so that I could print everything for the rest of the year. All right, so that's my total cost for LaserJet. And then what about the other piece? 6.95 times p plus 8.
Total cost for inkjet paper.
Exactly.
We have
And where in the problem do you see this explained?
where it says
After the
Where it says
LaserJet
she buys 8 more packages of
Mhm.
inkjet paper.
Yeah. She's buying 8 more packages of inkjet. 8 more packages of inkjet paper. So that's where the P plus 8 comes from, because P is laser, and then she's buying 8 more than the laser. Does that kind of make sense? It's a little confusing, but it's when you break it down, that's where you see that. So we know that this is the total cost for inkjet paper. And then all together, when you add those two together, when you add the total cost for laser and the total cost for ink, you get your total cost for your trip to Staples. Any questions?
me.
Go for it.
I thought we were going to find out the term for 6.95.
First, say that again.
I thought we were going to find out the term for 6.95.
For 6.95, well, that is the term. This whole thing is a term all by itself. Even though it's kind of long, it still counts as one term.
Oh, and then you use the term she buys 8 more packages of inkjet paper because like she's buying 8 more, and then the cost is 6.95.
Exactly. It's the cost times the amount. So that's how you get your total.
Okay.
Are there
Did you
questions?
say You said you didn't know what it is, and then you said you would buy it.
I just know it's paper. I just need paper all the time. I need
Okay.
more paper. All right. Okay, so we've worked on breaking everything down. Now, okay, I had a couple of ones for you to do on your own, but I want to skip. If we have time at the end, I'll come back to these because I just want to get to this one. Okay, this one's we're gonna work for like 10 more minutes, and then you guys will take your quiz. Okay. So now we're not going to break it down. We're actually going to write the expression. So in these two examples, they don't write it for you. We have to write it ourselves. So only write the actual problems. You do not need to write anything else. And we're going to write an expression based on these problems.
We write that?
Yes.
We write A or B.
Yeah, just A and B. Mhm.
Okay.
Okay. Starting with letter A. So we're going to write an expression for this statement. Whenever I see a statement and I know that I need to write an expression for it, the first thing I'm going to do is I'm going to, I say annotate it, which means I'm just going to like highlight and circle different parts of it and then come up with different variables and coefficients. So I know that, say again.
The quiz gonna be like expressions, or we gonna have to write the expression?
For the quiz, today's lesson is not part of the quiz. So the quiz is on everything else that we did this week. So solving equations, that's it.
Oh, okay.
Will it be in the future?
This, yeah. This will be next week's quiz. Okay. All right, so here we go. The price of an item plus 6% sales tax. Okay. This is where it becomes very important to know what sales tax is and how you calculate it, okay? So the first thing is we know there's how many terms are going to be in this expression. How many different things am I going to be writing down?
I believe.
Well, you gotta write an expression, right?
Mm-hmm.
I know you're gonna put like 6 in the expression.
Yeah, so this is going to be one term of my expression. Oh, it's not circling. So 6% is going to
We
be there
can't
somewhere.
see it. We can't see what you write on the thing.
Yeah, I know. I'm working on it. Okay. So 6% is going to be one part of it. And then the other part of it is going to be
The price?
You
the
put
price.
addition, the plus sign.
Exactly. We know it's going to be the price of an item plus the sales tax. So we're going to have two terms. Now, this is where I can come up with my own variable. So I can choose any letter I want. If I'm talking about the price of an item, what letter, anyone, what letter should I use? P? Okay.
Because I look like a 1.
That's true. Yeah, the I looks like a 1, so sometimes that's confusing. All right, so we know P, we're going to define our variable. It's always important to define what it means. So we're going to write P is the price of an item.
So we're doing our variables first.
Mm-hmm.
T for sales tax.
And then we're going to have our sales tax. However, the sales tax is not going to be a variable because we actually have a number. We have 6%. So what we're going to do is let's think about what sales tax actually means, okay? If there's a tax on an item, I see Juan raising his hand. Do you want to explain it?
Yeah.
Go for it.
So it's like it's a small percentage of an item that goes back.
So yeah, so it's a percentage of the price. So let's just think of a scenario. Let's say I have a toy that costs $10. That's the price, right? Price is $10. The tax
Oh, Miss Lopez.
is 6% of that.
Are we doing? I've learned this in Miss Sneed's class. You have to put like 100% down there.
It has something to, yeah, you're on the right track.
Oh no!
So the sales tax is 6% of $10. Okay.
Is it $60 or
That's where we have to.
60 cents? I think it's 60 cents.
You think it's 60 cents? So
yeah.
Let's think about it. So we're taking 6%. Is that a big percentage or a small percentage?
Small percentage.
It's a small percentage. So do you think out of these options, will it be 6 cents, 60 cents, or $60?
6 cents?
Maybe 6 cents. So we're going to expect it to be a small amount, right? Okay.
If it goes 60%, then it might probably be $60.
Then it might be 60 or something bigger, exactly. So yeah, 6% of $10 is 60 cents. So this sales tax would be 60 cents. Wait, no, sorry. I'm sorry. I wrote that wrong. 6 cents.
Wait, it's
Small amount. It would be a small amount.
But if it was $100, wouldn't it be $6?
Sorry, I keep messing this up. You're correct. You're correct. So it's just 60 cents. Yeah, I had it right the first time. How did I get $10? I'm just coming up with a random scenario right here. This is totally a random. I could have come up with any number. I just wanted to give an example. So if the cost of my toy, this whatever toy this is, was $10, and the tax was 60 cents, my total, I have to add them together. My total would be $10.60. Does that sort of make sense? So when you go to a store, this happens, you can go to Publix right now and go buy a $10, I don't know, what do they sell at Publix? That's $10. A $10
balloon, those little balloons.
Okay, sure, yeah. A $10 balloon thing. It says $10 on the price tag, but when you go to check out, it's actually going to be $10 and a little bit more because they also take that sales tax. So that's what sales tax means. Now, I'm going to erase all of this because this is not the actual question that we're doing. We're just going to write a general expression. We're not going to think about it with an actual price because the price is just going to be P. So how did I do everything I just did? Well, I took the price of my toy, which was $10, and I added 6% of 10. So what I did was I multiplied 10 by 0.06. I'm going to say that one more time. And again, don't stress if this is confusing. We're going to go over it again. This is not on the quiz. I just wanted to finish this part of today's lesson. When you have sales tax, you start with the cost of the item that you're buying. So that's my P. You start with the cost of that. You take 6% of it and you add it together. And that's going to be your final total cost.
And you multiply it by 6% instead of putting
Sorry,
0.
say that again.
Can't you multiply it by 6%? B by 6% instead
So
of 0.
good question. So the 0.06, that's the same thing as 6%. I just wrote it as a decimal instead.
Wouldn't it be 6/10 instead of 600?
Um, no, because with 6%, so I'm going to write this over to the side a little bit. The quick way to remember how to do this is if you put a little decimal point next to the 6, you have to move it over to the left 2 times. So that blank spot right there, that's the 0. That's where that came from. Because if you think about it, 6% is 6 out of 100, so it's 6/100ths. So I know I've confused all of you guys a little bit with this, and I don't want to end the day with confusion. So instead, what I want you guys to do now is we're going to spend 5 minutes. Let me skip all this. Oh, Khan Academy is due today. Do not forget to finish Khan Academy. If you have not made your account yet, stay after class to make it. Okay. So you're going to take 5 minutes now to review your notes from yesterday, especially. Those are the most important ones. The notes from yesterday, that's what you want to be reviewing right now. 5 minutes to do that, and then I will show you how to get to the quiz after 5 minutes. Okay, so I'm going to set a timer right now. You guys have time now to review. If you have any questions, you can type it in the chat, and then I'll show you how to start your quiz.